An example of a cube root function, and just like with the square root function, we need to identify the b hack and list our reference points. Okay, so in this example I just wrote it vertically instead of horizontally, the b hack, but it's up to you if you like it, if you like writing it the other way, that's fine. So again, just a quick review. The b and a are multiplied and the h and the k are added. Okay, so in this problem, b is, oops, didn't mean to write that, but b is -1 because the reciprocal of -1 is -1. H is +3. A is 1/2 and K is 2. Okay, so just real quick, the B came from here. The reciprocal of this number is -1. The H came from here. Okay, it says x minus 3, so remember, you take the opposite. So if you see the negative sign right there, so the H will be +3. A is 1/2. It's the coefficient of the square of the square root of the cube root, so that's right here. And then the K is the number that is added or subtracted at the end outside of the radical. Okay, be it a square root or a cube root, whatever it is. Now, in this example, I listed all 5 reference points. As I've told you guys in class, I usually stick with these 3. I don't use the 8s and because then they get too big too fast. But I think it helps, especially if you're struggling a little bit with problems like this one, to add the 8, 2, and -8, -2. So I just put them in there. Okay. So the first step is going to be to apply the b and the a. So that means that we're going to multiply all the b's by, oops, doesn't look like multiply, by -1, and all the a's by 1/2. So multiply by 1/2. So we get 8 -1. Then we get 1 -1/2. Then we get 0, 0. Then we get -1, 1/2. And then -8, 1. Okay, so the next step is going to be to apply the h and the k. So both of them are positive, so that means we're going to add 3 to the x's, and we're going to add 2 to the y's. So then I get 11, 1, 4, 2 minus 1/2 is 1/2. And then 3, 2, because 0 plus 3 and 0 plus 2. 3 minus 1 is 2. And then 2 plus 1/2 is 2.5. Okay, and then finally, -8 plus 3 is -5. 2 plus 1 is 3. Okay, so other than 11, 1, the numbers weren't too bad. So let's see, I noticed that almost everything is positive except for the very last one. So if it doesn't fit, it's not a big deal. So positive, positive, that's quadrant 1. Okay, so I'm going to make my x-axis really low right here on the paper, on the screen. So I'm going to draw the x-axis right here. And I'm going to try to fit in the 11, 1 since we took the time to, work with it. I'm going to try to fit it in. So I have, let's see, 1, 2, 3, 4. So I can just put it here, the y-axis. So 1, 2, 3, 4, 5. Okay, and then again, I'm doing the same thing as I did on the other problem where I'm counting every line on the graph paper as 1. So 4, whoops, okay, and that's enough. I don't need that part of the x-axis. I can just draw an arrow and label it x. On the left side, -2, -4, and extend it a little bit more, -6. Okay, so now we're ready to graph the points. I'll use red again. 11, 1, it's right there. 4, 1.5, approximately right there. 3, 2, okay. 2, 2.5, approximately right there. And -5, 3. Okay, so there you have it. So you have the 3 middle points right here. This is where the curve changes direction. Okay, so see, this is where the 8, 2 and the -8, -2 comes in handy, because there's no way you guys are going to draw the curve going up like this like you sometimes do, or draw a line, right? So again, just to be safe, that might be a good idea for you. Just keep the 8, 2 and the -8, -2. So I'm going to connect the points. Okay. And it doesn't, I know that on the left side it looks like it's flat, but it's not really flat. On the left side it does increase slowly.